everyone, and welcome to Responsible Assessment in the AI Era. I want to thank you all for coming, and especially thank our Dean, Dan Schwartz, and our CEO ETS, Amit Sabah. And I thought of doing this more than a year ago, before this building actually even existed, because I recognized that I was working with two different groups, my faculty colleagues at Stanford and my trustee colleagues at ETS, and both groups were thinking very deeply about how do we shape AI to inform and improve assessment. And I thought, we need to get these people together. So we intentionally convened this cross-sector group of researchers, practitioners, educators, assessment creators to engage in a discussion about how do we shape the current moment. So I'll just do a few logistical things, then I'll turn it over to Dan and to Amit to welcome you. So a couple things. Today we're going to have 4 panels, and I'll introduce each panel. Followed by the panels, we'll have breakout sessions. Now the panels are intended to be thought starters, so we're not having a lot of time to discuss during the panel, but I encourage you to discuss with each other over the breaks between panels, and also then to join the breakout groups that'll happen at 2:30 to where you can go in much more depth discussing with cross-sector people the ideas that are being raised in the panel. The main program, our first break will be at 10:20, and then we'll have lunch at 12:10 to 1 in this room. Downstairs, as you were coming up, you probably noticed very large poster boards. We're having a poster demonstration downstairs that is both ETS researchers as well as postdocs and doctoral students from Stanford. So if you haven't registered for a breakout session or know what breakout session you want to go to, there's information about them at the registration desk. You don't have to register. It's just good for us to kind of know to make sure we got the right room size for each group. And with that, I am going to first welcome, and with heartfelt thanks, to my dean, Dan Schwartz.
Okay. So this is the first time I've actually had a chance to speak in our new wedding venue, if you would like. So for this kind of talk, there's kind of 2 usual play patterns. One is to talk about how amazing Stanford is and ETS. So those of you who don't know, the School of Education is responsible for Chromebox Alpha. It's also responsible for meta-analysis. So Ingram Olkin created meta-analysis here. And I spoke to him, 20 years after, and he sort of regretted it. So it's an interesting conversation why he did that. Meanwhile, we've got something like ETS, an incredibly decentralized educational system. ETS is like a huge central force. So it's not that kind of talk. Another kind of talk is the soaring talk. This is the future of AI, right? And it gets images like this, and it's not that kind of talk either. So this is a more muscular talk, so hang on with me. So I want to talk about adaptive learners. I worry about discussions about all the things the tools can do without a vision of what it is we're trying to create and measure. So you can have sort of 2 visions of performance. They're not incompatible, but they do compete. One is mastery. So this is really useful for stable environments and tasks. Reading is a great example of this. Reading, it's always left to right. You can read the text. You want people to be really fast at this, accurate and consistent. So this is a model for a time when things were quite stable, right? A different version is adaptiveness. This is useful for changing environments and situations, right? And here, I think a lot of people are focusing on strategy and attitudes, and so I think the process data that you're going to get with AI is going to help with that. I just want to warn a little bit, strategies and attitudes are very state and context specific, right? And so you have to be careful when you think about this. Persistence isn't always good, is basically an easy way to remember it. But the thing I want to focus on is knowledge. and knowledge-driven adaptation. So if you look at the best predictors of year-over-year performance, it's how they did the year before, right, on various things. And so what you want is you want people to be able to apply their knowledge effectively in new situations as opposed to perseverating on what they already know. And then you want them to notice and learn from new information. If you don't see the new information, you can't adapt, okay? And not all adaptation is like to COVID, where it's just this huge upheaval. A lot of times it's much more subtle, and you need to see the information. So I'm going to make 3 points. Traditional instruction doesn't prepare people to be adaptive. Our assessments are misleading, and there are alternatives, okay? So this is, like I said, this is a muscular talk. Get ready. So here's how this study went. It was a fairly typical play pattern for university instruction. Students read a chapter that had 8 key concepts in it, and they wrote a 2-page summary. So a concept in psychology would be primacy. You remember the first things you hear best. So all of you are going to remember that I talked about meta-analysis, and you're not going to remember anything else I said. So this is primacy. So the students wrote a 2-page summary of a chapter, and then I looked at their summaries and I coded how many of the 8 concepts did they cover. Did they cover primacy? Did they cover recency? A few other things. Then a little bit later, they got a 40-minute lecture that described the concepts, that sort of gave examples, developed the theories and the experiments. Here's a sample explanation, right, which is some of the mechanism that was behind this. Okay. So then a few days later, I gave them a test of declarative knowledge, right? And so people tend to remember the first things they hear better than other things. True or false? When people don't understand, they tend to remember verbatim. True or false? They went through this. So the students were over 90% correct. They aced this. By this typical measure, the instruction worked really well, right? And this is what most faculty get. They say, oh, it worked really well. So let me show what an adaptive approach to this would look like on measuring. So a week later, I gave them the description of a novel experiment they hadn't seen before. It was in a different context and things like that. And their task was to predict the outcomes. And all of the 8 concepts that they had covered would be applicable to this situation. So I looked at their predictions for this experiment. I coded how many of these concepts did they use. So that's what I'm going to show you. So did this study a couple of times. Here are 2 of the studies. In study 1, if students noted the concept in their summary. For example, some students noticed primacy in their summary. The question is, what are the chances they use primacy to predict an outcome from the new experiment that I asked them to make predictions from? So the odds that they would use something that they summarized to make a prediction is about 26% and then 23%. Okay, so we don't know if this is good or bad, right? Because we don't sort of have a baseline for this. Here's the part that's particularly important. If the students didn't get the concept in their summary, did they pick it up from the lecture such that they used it? So some students didn't include primacy in their summary. What are the chances they used what they learned about primacy from the lecture to predict an outcome in the novel experiment? Make sense? Right, so what did they learn from the lecture, not from the summary, that they could use? So basically, from the lecture, they learned 6% of the content that they could use. So this is horrible, right? Without any baseline, this is horrible. If my colleagues knew that when they gave a lecture, the students were only going to pick up 6% of what they say that they didn't already know, I think they would be taken aback. So I've run this study in math and science at different ages. You get the same thing over and over from our standard ways. Okay, so my job isn't to just destroy the world. It's also to offer an alternative. So here was a different approach, preparing them to be adaptive. And it comes from science of learning. The students received data sets from experiments that demonstrated the 8 concepts. And their task was to look through the data and graph what they thought was interesting. So I didn't tell them, you should graph this or that. They just looked at the data and they said, oh, there's a pattern I'm going to graph. And like before, I could code which of the phenomenon, the concepts did they cover. So here's an example of what their tasks look like. Graph the important patterns you see in the data. They then get this background information. These data come from an experiment. Participants try to remember a list of words. They then see the words that the participants heard, and then they see what the participants remembered. So they're basically getting the description of an experiment and the data, and their job's to find the interesting patterns. This is sort of a fun task, sort of, but I'm gonna shortcut it. This is recency. The last thing you hear, you remember first. So you can see all these people remembered bag early on, right? So then this would go on. They would get another data set under new conditions. Here they get the description of an experiment where after the participants heard the list of words, they counted backwards from 99. So this sort of wipes out their ability to rehearse the words they just read. This is what they remember. The students analyze this. If you look at this, you get recency or primacy. They remember the first things in the list first. So this is their task, okay? So it's quite different than reading a chapter. It's not sort of a description of a set of propositions about what you should know. So these students then heard the exact same lecture. They were in the same class, right? And they completed the memory test as well. And so they were about 90% accurate or above. So it was the same as the other condition. So everything looks good, looks the same. And then they completed the prediction task. So if the students graphed the data, these are the odds they would make a prediction of the new experiment that they had never seen before, of one of the things they discovered. So this is 3 times greater adaptation in new situation than the students who wrote the summary. Then you get the ones who, if they never saw it in the graph, did they learn it from the lecture? And here you can see a 4-fold advantage. So not only are they able to apply their knowledge in a new situation and figure it out, but when they're confronted with new information, they learn it in a way they can use it. Of course, there's a third condition where they just graph. They never heard the lecture, okay? And so to make sure it was same time on task, they graph twice. They'd find it and they'd say, go find some more, right? And that was okay with them. They did poorly on the test of declarative knowledge. If I asked them any of those propositions, they didn't know, right? And they did really badly on the prediction task. So it looks like this. If the students had graphed the data, the chances they'd make a prediction was low. And if they missed it in the data, the chances they'd make the prediction were also low. Okay? It's a complicated set of results. So there's a lot of interesting patterns, reasons for this. I think the answers to that, to why this happens, could guide the design of assessments. But for now, I just want to do the practical implications. 1, traditional instruction doesn't prepare students to adapt, right? You get poor performance on the prediction task, right? We're teaching them the wrong way. We're teaching them for mastery, not adaptation. We also didn't prepare these students to learn anything new from the lecture. It's sort of stunning. They go in and they listen to this lecture and what they learn is what they already knew. They don't hear the new information because they think they know it. So this is an interesting story. Second, our assessments are misleading. The summary students did well on the declarative knowledge test, and the graphing activity by itself looked useless. They did terrible on that test, right? They were at chance. Right, so our measurements, if we want to use it to help us design instruction, which everybody does in schools, right, better get it right. And here they get it wrong because they eliminate really important kinds of learning activities. So what this study really was a study of a dynamic assessment. So a dynamic assessment was come up with a guy named Feuerstein, and he did this for children with intellectual disabilities. He would give them IQ tests and they would do terrible on it, right? And what he learned was, let me teach them how to take an IQ test and see if they learn from my instruction and do better. So this kind of assessment where you teach as part of the assessment and see what they learn was a big deal. It turned out to be much better for deciding whether these kids could go forward in school. What I showed you was a dynamic assessment, right? What happened here was the lecture was part of the assessment. Did they learn from it? So I'm measuring, are they prepared to learn, right? And then could they adapt what they learned to this new information, which is the prediction task? And then finally, I showed the value of these pre-mastery things. Like the students who did the graphing looked terrible by any mastery measure, by any measure. Yet it turns out those kinds of things are incredibly valuable. And so the way you measure those have to be things like a dynamic assessment as opposed to a straight up summative assessment, which is what a lot of our current tests do. Okay, so let me end with something that's a little vast. Do we need adaptive learners in the age of AI? Right, so one of my favorite stories is from a faculty member where the faculty member tells the students, you write your essay in ChatGPT, I'll let ChatGPT grade your essay, and we'll just all go to the beach. Right, so I like that story. It's kind of an apocryphal vision of the future. So in one model, it's possible that AI will be designed so that people don't need to adapt. Right, so the military did this. They had this challenge, they had this very complex equipment, and they were trying to train their cadets to be able to use this equipment. They finally gave up and said, let's just make the equipment easier to use. Right, and so maybe the AI just becomes, solves everything. For now, I think our knowledge bases, our tools, our circumstances, our jobs continue to change. So we need instruction that produces adaptive learners and assessments that can tell. Okay, that's my message. And we're not there, but I do think we could be. If you want to know more, there's a paper you could read, and it's not hard to find. I paid like the extra $1,000 so people could get it. Okay, so now let me go back to the vast. Right, I want to introduce Amit. Right, so Amit is, as all of you should know, he's the CEO of ETS, which has been an incredible leader in educational research and measurement. They've been valued partners in helping us convene today. They put their branding on the table, so I don't have to show it up here. Oh, please. Okay. So Amit has led ETS's work advancing measurement science and supporting upskilling and reskilling efforts, which I think is a very interesting direction for more than 50 million people each year. He's here to help us think about how we can meet this moment. On a personal note, Amit is the best dressed person you will ever see. And you should appreciate that. I actually decided to wear a sport coat, so I wasn't too embarrassed. So Amit, please, and thank you.
Good morning. That was fantastic. Thank you, Dan, for your muscular talk, your muscular leadership, the incredible role you're playing in galvanizing this community, the interdisciplinary approach, and really just talking straight about the challenges, but giving us hope about the opportunities that research and data and insights can be. So thank you so much for your leadership and for having us today. Candace, you're a phenomenal bridge builder. You really brought us together today. This wouldn't have happened without you. And I am personally so grateful for what you do to support us at ETS and really pushing our thinking on evidence as the foundation for great assessments, going beyond testing. And how do we develop creative ways to think about evidence, data points that are valid to really bring measurement forward? So thank you so much for bringing us all together. And to Isabel Howe, the leader of Stanford Accelerator for Learning, really just thank you for your spirit of partnership and collaboration. So thank you so much for everyone here at Stanford. And I want to thank you all also for really building this building for us today. You really didn't have to do this, but just the effort that the Enko family, just really appreciate that. So we're actually here as ETS on the West Coast, which is a little bit of a different tune for us. As you may know, we're based in Princeton, New Jersey, and we've annually been having our annual convening in Washington, D.C. But we thought at this moment, at this time, when we want to have conversations that are rich and deep about how does research and policy and technology and education come together, there is really no better place than through this collaboration with Stanford to have this conversation, to step out of the Washington bubble and really talk in an anchored way around technology and research. The theme of today's session is responsible assessments in the age of AI. And I'm really inspired by this topic, particularly responsible, because in this moment in which AI is ripping through education with all these experiments, with all this that's happening, the real question is what's working, what's not working, and how do we safeguard and protect our children and support our teachers effectively in this transition? We don't want to have fragmented measures we want to have continuity. And this may be going beyond the hype of AI in education to actually the hope of AI in education by thinking about how we can connect the layers of data points that build evidence at a student level, at a teacher level, at a school level, at a state level, at a national level. We can connect these dots, but we have to be planful in how we do that and do that responsibly. We want to measure what matters. And we're all here because we care about the future of education. And this question of how do we measure the outcomes around that is really what today's conversation is all about. For decades, we've been circling around some of these truths. Terence Bell, the former Secretary of Education, commissioned A Nation at Risk, a clarion call to talk about how do we move beyond as a nation mediocrity in outcomes in math and reading, challenges that teaching was having. That was 40 plus years ago, back in 1983. In 1984, anchoring it in research, Benjamin Bloom wrote the 2 sigma problem. This concept about how do we get incremental gains in performance, 2 sigma improvements, through personalized tutoring and planful support of that student. And 2 sigma means if you take a classroom that has an average, let's say 30 students and the average student's at a 50th percentile, 2 sigma means over 95%. You're taking an average student to become exceptional with high impact personalized tutoring and learning support. This has been the holy grail. We've been talking about this, and you've seen lots of ed tech companies, lots of research around how do we drive personalized learning. And I know addressing learning differences using AI is a big theme here at Stanford. And so for us, a lot of these truths are back from the 80s. We have a national problem, right? And we also have a classroom problem of how do we actually deliver 2 sigma high performance outcomes effectively. You know, in 2021, right on the heels of COVID as a nation, we started the journey of figuring out how do we recover from COVID. As a country, we invested $190 billion to make up for the learning loss during COVID. This was a once-in-a-generation moment to really impact outcomes and experiment and try new things. And what breaks my heart is that big investment, we don't really have great measurable outcomes on all of those dollars spent. That great experiment didn't produce measurable outcomes. Look at the NAEP scores. We as ETS administer NAEP, we're grateful to be the stewards of the nation's report card, and we all know the results. The math and reading results for 4th and 8th in high school. And so all this experiment, all these reform movements since the 80s haven't produced results, even though we know we have these 2 fundamental challenges at the national level and at the classroom level. We have a macro problem in education and a micro problem in education. Enter AI. The question is, how do we responsibly leverage AI to address this 2-level problem? We have over 70 million learners today, 70 million children, 70 million students in formal school education in the United States, let alone the world. We've got over 1.5 billion students. Think about India, think about Africa. We have so many students today in formal education, still in traditional micro classrooms. And so we know learning is accelerating. We know the pace is moving quickly. And yet measurement, what we do for a living, what research does in some ways, very much so for a living in trying to measure outcomes from different experiments, hasn't quite kept pace with this rapid change of all of these different experiments. So we have to move beyond just thinking about a test as something we do at the end, and thinking about these interim, thinking about these formative, and thinking about continuity of data. Because what AI can provide, the beauty of AI, is based on reliable, high-quality, structured data. Tests is a moment to collect data, to apply AI effectively, but only if it's structured well for actual outcomes that matter. And so as AI is accelerating, we can't mistake the fluency with understanding that students have. We can't mistake confidence that a student shows with actual competence inside. And we can't mistake speed for actual mastery or adaptability, as Dan just said. It's not just going faster that AI is producing, it's actually taking a moment and understanding what's the outcome we're striving for, what's the learning we're striving for, or the life chances we're trying to change in that student, and how can AI help with that? Responsibility writ large. And so this is actually the exciting moment right now for us. As we think about researchers like Benjamin Bloom, or we think about the research of Vygotsky in the zone of proximate development, this zone of the learning edge, that there are these moments when you can really capture advances through support over time. Again, there's been research out there, there's foundations out there, but how do we actually make that happen? And where can AI play a role in helping nuance that learning? And this is where complex skills come in. This is another theme at ETS we're starting to get focused on. There are foundational skills, math, literacy, and other core skills. Those matter. Those are still very much relevant in the economy and the society we live in. But on this point that Dan just raised around adaptability and thinking about adaptive learning, what are other skills that are out there that are around this, and how do we actually effectively measure this? So this concept of going beyond math and reading, foundational, but going and recognizing that the world that we're in is a world in which we're building individuals that are in a lot of change and a lot of flux and a lot of fluidity. So the communication, the critical thinking, the creativity, something studied here, the curiosity at Stanford, I've seen Helena's work on this. There's a lot of things happening at this moment that allow us to think about what we measure as well as how we measure it differently. Because the what of math and reading is critical, but there's so many other whats, and the how of going beyond a standardized test or a multiple choice test to iterative assessments or testless assessments is a really exciting moment. The what is changing and the how is changing at the same time. And that's what makes this both challenging, but also quite exciting for us as researchers. We need strong infrastructure, a public good around investing in this type of work. And that's where ETS just announced last week that we're launching a new Center for Responsible AI. This is a big initiative. We've been working on this for over a year, and this is the first step. We're going to be commissioning papers, convenings, striking new partnerships, and really making this a real big focus of responsible assessments in a world of AI. We're really excited about this partnership with Stanford. Much more to come around the collaboration. Responsibility has many meanings to it, but one of those is fairness. What's really fair? And I want to invite us to consider that this is not something we can bolt on at the end. We learned over the last decade from the social media experience, right? We learned that we were all excited about social media and students getting engaged, and there might be some ed tech opportunities and some new ways to learn. But then we saw the dark side, the challenges that teenagers had, that students had of engaging, and then we pulled back as schools are pulling back in different ways. This is a moment right now where the way AI is ripping through our educational system, we have an opportunity to get ahead of it, to have some common sense around it. And so this involves policy and recommendations that are based on evidence. So that's why there's urgency to the moment right now in January of 2026 that we think about what is this year going to be about. We know those models are going to get better. We know that all of those hyperscalers, the AI companies are going to continue to produce what they're producing. But our job is to think about the human implications of those for students, for policymakers, and for teachers. And that's why this is an urgent conversation that we're having today. This matters because our kids matter, and we know we can do better. I have 3 kids, 2 in college and 1 in high school. We're constantly in conversation about this role of AI. And I know, while I don't know what they're going to do after college, or careers and lives and jobs are all evolving as they go, I do know that if we can, as educators, as researchers, as policymakers, ground this in responsibility, we have a fighting chance to help them be successful. Thank you so much. We're super excited about today's session. Much more to come. Let's not miss this moment. Thank you.